Alright, so we're going to start with a bit of a preamble for Lesson 3. So Lesson 3 is covering correlation, regression, and scatter plots. So let's say that we have data from, we've measured plants, so let's say we've measured some wild onion plants, and for each plant we've measured first we measured plant height, so the height of the plant, and then we've counted the number of seeds that plant has. So for this we've counted 15 seeds, and we have these numbers. And what we're going to do is first, to make a scatter plot, is that we're going to map each one. So each point on this graph is one plant. So let's plot these out. So first here we have plant 1 is height 10 centimeters. You can see we have plant height on the x-axis here on the bottom. And then on the y-axis here we have number of seeds. So on the first one we have plant height of 10, we have number of seeds as 24, so here's a point. Then 12 and 35, so here's a point. 18 and 49, that would be about there. 20 and 56, about there. 10 and 29 would be here. 12 and 34 would be about there. 14 and 39, that would be here. 9 and 30 would be here. 22 and 68 would be about here. 19, 56 would be about there. Well, that would be to the right of that point, wouldn't it? It would be about there. Then 11 and 32. 11, 32. 13 and 32. There. 17 and 41. There. 15. 38. There. 23 and 74. Up there. So you can see here that each point that I've drawn out here represents one plant that I've measured. And so this type of graph is what we're going to make. So this is a scatter plot that I've just created, where I've created a quantitative variable and a quantitative variable. And then we can do all sorts of analysis based on this. And so this is what the lesson will cover. But I just want to make sure that you guys understood that each point on this graph represents a measurement from a single individual, whatever it may be. This could be a plant in this case, or it could be maybe you measured a hedgehog, or maybe a small mammal, or a bat, or a snake, or an argali, whatever it is that you measured. You have two measurements on it, on that one individual, and so you're going to relate them how they are, and so each point represents one individual organism that you measured.